Hey everyone. I've been meaning to put up some videos on electronics for quite a while now, but I realized that I have this problem where I wait for too long for things to get perfect and everything to be set up just right before I even get started. And so this time I was like, you know what? I'm just going to get into it. So let's do this. Okay. Imagine that one day you wake up and all of a sudden you find that, hey, I've got the superpower. What's the superpower? It's a very unique superpower. You're able to move, you find that you're able to move these specific pebbles from one place to another with just the power of your mind, like without touching them, telepathically. So you may think, this is it's not really all that useful a superpower, is it? But hold on. If you think about it, if these pebbles are in an interesting enough environment, you'll actually be able to do quite a lot with them. So, for instance, let's say you want to create sound. You're able to take these pebbles and strike them on various surfaces, and you've got sound. And say you want to create heat. You're able to take these pebbles and like grind them against each other or against other surfaces, and you get heat, which is pretty cool. So now you get heat wherever you want. You're also able to move things. Things like seesaws. So for instance, if you see a seesaw out in the distance, you can move a bunch of your pebbles telepathically, put them on one end of the seesaw, and it goes right down and you're able to create movement. In fact, you can also connect a lot of cool other contraptions to this seesaw and control the movement of all of those things too with this like switch seesaw thing. But anyway, you may be wondering, okay, Spriya, thanks a lot for this imaginary ride, but what's going on? Like, why are you telling us about this silly superpower? The reason I'm telling you about it is because we humans actually have figured out a way of having the superpower, but it's not being able to move pebbles. What we're actually able to move are these tiny, tiny little particles, small pebbles, like tiny particles called electrons. So you may wonder, okay, well, what are these electrons? What's the deal with all of them? We'll get into this just a little later. In fact, this whole field of electronics is about these electrons. But the cool thing about this is that once you get electrons to move, you're able to do all sorts of fun things with the environment. Like just on its own, it's actually not all that useful. But because you put them in an interesting environment, you're able to do cool things with these electrons, just like you can with the pebbles. So you may ask, hey, Spriya, like, how how do you even move these electrons in the first place? You say we've got the superpower, but what do you mean by it? So it turns out these electrons actually are not all that difficult to move. These things are like these particles, they have this quirk where they just hate being with each other. So they hate being in these like crowded, electron packed, like overcrowded spaces. And so what they really want is to be able to move away from each other and just into like freer lands. They just need space to live. So what you can do is, and what we figured out of many ways, or what we figured out many ways of doing, is we have a bunch of like overcrowded electrons, like a space full of electrons, and then what we do is we bring a place, like a little space near them, that like a material or something near these overcrowded electrons that doesn't have so many electrons on its own, but has a lot of space for new electrons to come join in. And so what happens is in these overcrowded electrons, you now have this irresistible urge that they find themselves having to move over. They really want to go over to the other side. In fact, if this urge is big enough, they will move over. What do I mean by this? So this urge of moving over, like they just hate to be with each other. So this urge of like transferring, that's called voltage. So this word voltage, it basically means how much pressure do these electrons feel? Like how much do they want to move over to greener pastures, let's just say. Um, well, that's enough theory. Let me show you what I mean. So let's actually check out some points of around my house. Of some places where we can compare the voltage, meaning we can see how much the electrons want to move from one point to another point. So I have this thing called a multimeter right here. What it does is it helps me measure the voltage. Hold on, can you see this? Okay, you're able to see the reading-ish. But yeah, what this does is it basically tells you how many electrons, like approximately, want to move from the place that I touch the black probe to to the place that I touch the red probe to. Meaning, if there's a lot of electrons wanting to move from this place to this place, you'll see a very high number. And if there are not too many electrons, you'll see a low number. In fact, if there's no electrons that really want to move, you'll basically see 0. So let's compare. As you can see, I've set the multimeter to volts, V. All right, so let's see my skin here. So I have my skin. Let's see what the voltage is between two different points. Do you see the reading? Well, I don't know if you can see it, but there it's 0. You can't really, so basically you can't really see any voltage. What this means is electrons don't really want to move from this point in my skin to this other point in my skin. So all right, that's to be expected. Why don't maybe we'll have better luck with this cashew. So this cashew nut over here might have some voltage. So let's see if electrons want to move from this point in the cashew to this point in the cashew. Da, da, da. Whoa. Do you see it? Okay, there you go. Yeah, no, reading still says 0. Nothing. No voltage. Too bad. All right, let's actually now move to something more electronic looking. So this pair of headphones. I don't know if you see it, but anyway, I've got a pair of headphones over here. Okay. Let's try and compare the voltage across these two ears. So this ear and this ear. Do you see any voltage? I don't see any voltage. It says 0. I don't know if you can see it, but god damn it, there's a lot of glare, isn't there? Okay, hold on. Okay, there you go. Yep, 0, no voltage. But this is like plastic or foam or whatever this is. It's to be expected. Let's try something metallic, because we've all heard that metals are, more electronic in nature. Whatever that means. So I have the plug of that comes with these headphones. So let's see if there's a voltage. Okay, connect this. Maybe on this side. I don't. Hold on. Do you see a voltage? Nope. 0. What? That's strange. There's no voltage even in this electronic looking thing. Okay, let's move on. Let's find, here, I have this little battery that I got off of Amazon. So let's see if there's a voltage here. So there you go. You see I'm just covering this so there's no glare. But here. Oh, what? Look, there's it's turned to 1.60. Okay, that means there's quite a few electrons that want to move from this black end to this red end. Yeah, that means there's a 1.6 volt voltage. That's pretty cool, huh? But I mean, these two ends here, these two parts of the battery, nope. It's only these two, the two ends. All right, that's pretty cool. That means you can actually give them a path, give those electrons a path to move, and they'll take it. They'll actually move. So how about this bigger battery here? So, if I put them on the sides, nope, no voltage. But if you put them down here, you get to see a negative. I'll talk about the negative in just a second. But yeah, if you touch them here, whoa, look at that, 9.64 volts. Wow, that means a lot of electrons want to move from this point to this point in the battery. No two other points, because this point to this point, they don't really care. This point to this point, nah, nobody really wants to move. But this point to this point to this point, a lot of electrons want to move. So what I meant when you just saw the negative sign pop up, right? So that was because when I flipped the cords, like the probes, this negative sign basically says that not only do electrons not want to move from the black end to the red end, they want to move in the reverse direction, from the red end to the black end. So that's the negative. So it's negative 9.6 in this direction, 9.64 volts. Cool. So that means with this battery, if you actually give a path to the electrons to move from this one point to the other point, they'll take it and they'll actually move. And so what does this mean? This means that if we're able to actually move the electrons from that one point to the other, from this point to this point, we're going to be able to do all sorts of cool things along the way, just like we could in that pebble example. So yeah, we're able to light up bulbs, we're able to power up an iPhone, we're able to do all sorts of cool things with electricity. So yeah, that was pretty much it. That's my voltage video. I'll talk next time about some of the cool things you can do with these electrons when they're moving around. We'll talk about currents and circuits and other fun stuff. All right, thank you so much for watching.